Heat is the energy of motion at molecular levels. It can affect the behavior of particles within a substance.
The formula is delta Q equals mc delta T, where delta Q is the heat energy in joules, m is the mass of the substance measured in kilograms, C as the specific heat capacity, and delta T is the change in temperature.
Law of conservation of heat energy. Heat lost plus heat gained equals to 0, or heat lost equals to negative heat gained. Heat lost is a negative value, and heat gained is a positive value.
It follows the law of conservation of energy. The total energy of any closed system always remains the same.
When a substance undergoes a change in state, the temperature does not change. This has something to do with latent heat. The substance does not change temperature unless all of the latent heat is stored or released. Latent heat. Latent heat is the energy stored in an object. It is associated with the object's change in state. It is the amount of energy required to change the state of a kilogram of a certain substance. It is measured in joules per kilogram.
Latent heat of fusion. The latent heat of fusion refers to the amount of heat energy required to melt 1 kilogram of a solid into a liquid. The value would be negative if the case is to freeze a liquid into a solid.
The formula for latent heat of fusion is LF equals to delta Q over N. LF stands for latent heat of fusion, which is in joule per kilogram. Delta Q stands for total heat energy, which is in joule. M stands for mass of substance, which is in kilogram.
Latent heat of vaporization. Latent heat of vaporization is the amount of heat energy required to vaporize 1 kilogram of a liquid to a gas. The value would be negative if the case is to condensate a gas into a liquid.
The formula for the latent heat of vaporization is LV equals to delta Q divided by mass. LV stands for latent heat of vaporization, which is in joules per kilogram. Delta Q is the total heat energy in joules. M stands for the mass of the substance in kilograms. Three types of heat transfer. The first type is conduction. Conduction is to transfer heat energy through particle collisions, like this. The second type of heat transfer is convection. Convection is to transfer heat through a circulating path of fluid. The hot fluid rises, and then the cold fluid flows in to take the space that the hot fluid is displaced, like this. The third type of heat transfer is radiation. Radiation is the heat transfer through a waveform of electromagnetic radiant energy, such as the sun. And here's a demonstration. Oh, the sun! It's hurting my eyes! Oh, it's just sunny.